As a student dreaming of curing diseases, imagine this: a hidden enemy multiplying endlessly within us. Cancer! To fight the best, we need to catch it early. How? By using a flaw-in diamond smaller than a grain of dust. Inside a diamond, swap one carbon atom for nitrogen and leave a hole next to it. You've created a nitrogen vacancy center, an atomic scale imperfection that acts as a quantum sensor. The diamond envy center is like a super-sensitive compass that can detect the faintest magnetic fields nearby. Its extreme sensitivity could one day help detect cancer cells at very early stages, when only a few rogue cells exist. Think of a diamond's quantum sensor, like a glass dome, with the envy center as a bulb inside of it. Then, shine a green laser beam at the bulb and bright red comes out. But when the envy center senses nearby magnetic fields, that red glow gets dimmer. Here's the physics behind it. The envy center's electron spin shifts when a magnetic field is present. Scientists can read that shift because it changes the intensity of the red glow. So how do we detect cancerous cells? We look at the difference in the red light. Scientists use cancer-seeking molecules armed with tiny magnetic labels. When these molecules attach exclusively to a cancer cell, they create a distinct magnetic field right at the target. The envy center then senses the signal, causing its red glow to dim, an alarm whispering, "Cancer found here." In the future, scientists hope to shine laser light and map cancer signals in tissue or the body, far earlier than methods like traditional MRI. And early detection matters. It's like fighting a few gangsters instead of an entire army. The sooner you spot the threat, the better your chances of winning. With this, Diamond Envy Center shows that imperfections can be really useful too.